Hey everyone, ever wonder how AI can solve a math problem or figure out a puzzle without being told exactly how? Today, we're diving into a breakthrough that's changing how smart machines learn, without needing mountains of data or supercomputers. Let's break it down. So here's the big question. How do AI models learn new skills? Traditionally, they'd need thousands of examples to get good at something. But what if they could learn from just a few? That's where this research shines. They developed a method called MAPD, Meta-Adaptive Prompt Distillation. Think of it like a teacher who gives you just the right clues to solve a puzzle, instead of teaching you the whole thing from scratch. Here's how it works. Instead of retraining the entire AI model from scratch, which takes ages and a ton of data, MAPD focuses on fine-tuning just a small part of the model, the attention mapper, for just 30 quick steps using a handful of examples. It's like giving the model a tiny nudge in the right direction, not overhauling its entire brain. Now let's talk numbers. In their tests, this approach outperformed other top models on tasks like OpenMI, a test for rapid image understanding, and operator induction, a puzzle-solving challenge. Even cooler, their model used 1.3 million vision language examples, a fraction of the 10.4 million data points other models relied on. And while those bigger models had billions of parameters, MAPD only tweaked 24 million. That's like using a small, precise tool instead of a sledgehammer. But here's the magic: meta-learning. The model isn't just memorizing examples, it's learning how to learn. By simulating thousands of tiny training sessions during development, it becomes super efficient at adapting to new tasks on the fly. And when paired with in-context learning, where the model uses the few examples provided to infer patterns, it's a match made in AI heaven. Take a math puzzle, for instance. If the model sees 1, 8 equals 8, it has to figure out the hidden operation. The answer? Multiplication. But how does it reason through it? The researchers graded answers strictly: 0 for off-topic, 1 for mostly wrong, 2 for partial credit, and 3 for clear, correct reasoning. A perfect answer would explain, the two numbers are 6 and 2. The operation is multiplication. 6 times 2 equals 12, that's a 3-3 spot on. But here's the kicker: even smart AI needs context. Just like you struggle to solve a puzzle without clues, models rely on examples to learn hidden rules. The study showed that giving more examples, like 16, 32, or 64 shots, improved performance, especially for tasks like operator induction. Now let's zoom out. Why does this matter? Imagine a smartphone app that answers visual questions without hours of training. Or a robot that learns new tasks on the fly by seeing just a few examples. This tech could make AI more efficient, faster, and accessible to everyone. The researchers tested their method on a benchmark called VL-ICL Bench, which checks how well AI understands images and solves problems. The results? MAPD consistently beat other methods, proving it's a game changer for small models. For example, when faced with a blurry image of a cat, MAPD still guessed cat with 77% accuracy, while other models struggled. But here's the technical kicker: MAPD doesn't just rely on raw data. It uses soft prompts, gentle nudges that guide the model to focus on key visual clues. These prompts are paired with an attention mapper, which acts like a spotlight, filtering out distractions. This combination lets the model ignore irrelevant details, like noise in an image, and zero in on what matters. So what's next? This isn't just about better AI, it's about smarter, more efficient AI. From helping doctors analyze medical images to chatbots that understand complex visuals, the possibilities are endless. If you want to see how these techniques work in action, let me know. Maybe we'll tackle a real-world example in our next video. Thanks for watching. Hit subscribe for more deep dives into the AI world, and drop a comment below. What's your favorite math mystery? See you next time.